In section 12-4, we're going to be talking about limits of sequences and whether they converge or diverge. So let me give you a couple of the definitions here. So a sequence A1, A sub 2, A sub 3, so on, you have terms of a sequence with a limit of either 0, so you get 0 that the terms are approaching, or another number, so not infinity or does not exist, as n approaches infinity, is said to converge. And basically, converge means that the terms approach a value. So if the limit of a sequence is 3, then all the terms are getting really close to 3, so it converges to 3. So on the other hand, a sequence with a limit of either infinity or does not exist as n approaches infinity is said to diverge. So if you ever get infinity or does not exist as your limit of your sequence, then it says to diverge. And the reason is the terms don't approach a single value. So once again, if your limit is a number, then it says to converge, the sequence converges, and if the limit is infinity or does not exist, then the sequence is said to diverge. So what we're going to be doing is we're going to be finding the limits just like we did before with functions. So in this case, we're going to be having the same rules for finding limits applying with sequences, and you're going to basically be looking for the dominant term if you can. If you can't find that dominant term, then what you're going to want to do is write out a few terms to see what they're approaching. I'm going to give you a couple examples for you to determine whether the sequence is convergent or divergent, or converging and diverging. They call it convergent and divergent. So here we go. So in this first example, the sequence is a sub n equals n cubed over n plus 4. And so what you would notice, if I wanted to find like the first few terms, and you don't have to do this each time, but I just want to show you what you do. Find the first term, you plug in 1, so you'd get 1 cubed over 1 plus 4. And so you'd basically get 1/5. And then the second term would be 2 cubed over 2 plus 4, or it would be 8, 6, and then if you plug in 3, you'd get 3 cubed over 3 plus 4, so you'd get 27 over 7, and so on. And this would continue for n number of terms. And we want to see what these terms themselves are approaching, if they're approaching a single number, seeing if they're converging to a number or diverging, not approaching anything. So what you're going to do is just find the limit as n approaches infinity of what the sequence equation is. So we have n cubed over n plus 4. So remember, limits at infinity, we're looking for a dominant term. If the dominant term is in the numerator, then that means that the limit is infinity. So because the limit is infinity, then that means that this is divergent. And when it's divergent, that means that it doesn't approach a single value. They're not getting really close to the same number. So in this next example, it's kind of hard to determine what the dominant term is. You look at, oh, it's an exponent, but what is that going to really do? So I told you before that if it's hard to determine the dominant term, write out a few terms of the sequence and then see what they're approaching. So if I were to plug in 1, I would get 5 times negative 1 to the first, or negative 5. Then I would plug in 2, I'd get 5 times negative 1 squared, or positive 5. And then I'd find the third term, I'd get 5 times negative 1 cubed, so it goes back to negative 5. And then the next one would be negative 1 to the fourth, which would turn out to be positive. Notice how they're oscillating between 5 and negative 5. Whenever this happened, that means that the limit does not exist. It's going back and forth. So because it does not exist, so we'd have the limit as n approaches infinity doesn't exist, then we would have a divergent sequence. Alright, so let's go on to the next example. So this next example, we have this sequence, 28 over n cubed, and then we have that multiplied by n and n plus 4, 2n plus 1 all over 8. So we're going to try to find the dominant term. And remember, when we find the dominant term, we're looking for the highest exponent. Well, if I were to multiply all these out, it looks like the highest exponent would be n cubed. So I would have a 28 times this 2, which would give you a 56n cubed plus, we don't really care about what the rest of it is because we only care about the dominant term. And this is all divided by, when I multiply these two, 8n cubed. So it looks like we have the same dominant term. And so that means we're going to take the ratio of the coefficients. So if I were to take the limit as n approaches infinity of this 56n cubed over 8n cubed plus, and this would be continuing forever, we would just get 56 over 8, or 7. So because the limit is a single number, that means that the sequence is convergent, or so therefore it converges. Okay, so our next example, we'll give you a cosine one. So in this example, it's hard to find a dominant term, can't really do that. So you're going to have to, again, start by writing out the first couple terms. And in order to do that, I'm going to probably need to use the unit circle, because I'm going to plug in 1 to get the first term. So I get pi over 2 times 1, or cosine of pi over 2. And then for this one, I'm going to need to find cosine of pi over 2 times 2. Well, the pi, or the 2's are going to end up canceling, so I need to find the cosine of pi. And then the next one, I'm going to have to go ahead and plug in 3, so I get cosine, and then I'm going to get pi over 2 times 3. So that's the same thing as cosine of 3 pi over 2. So I'm going to go ahead and get that unit circle. So remember, cosine is the x-coordinate, so I'm going to find the x-coordinate at pi over 2, so it looks like I end up getting 0. Alright, next one, x-coordinate pi is negative 1. Cosine at 3 pi over 2 is 0 again. And if I wanted to go one more for fun to find this, I'd do cosine of pi over 2, and I'd go ahead and plug in 4. So when I simplify that, that goes in there twice. I'm going to find cosine of 2 pi. So cosine at 2 pi is going to be 1. Notice how they're all over the place. They're oscillating. So because of this, the limit as n approaches infinity of the cosine of pi over 2 times n, it does not exist. So what I can say is, therefore, the sequence is divergent, or diverges. Alright, and here's the final example I have for you. So I want to know if this sequence converges or diverges. So again, you're going to locate the dominant term, and then you're going to want to take the limit. So what's the limit as n approaches infinity? Of n plus 3 over n squared. And because the dominant term is in the denominator, that means that the limit for the sequence is going to be 0. So that means that all the terms would get smaller and smaller and smaller and approach 0. So therefore, we're going to say the sequence converges to 0. Alright, so that's it. That's sequences. It's really similar to what we did in the section before this, and that's it. So I will see you guys tomorrow. Have a great evening.